Welcome to Mind Vault, your go-to channel for unraveling the mysteries of the universe. I'm your host, and today, we're taking a deep dive into one of the most enigmatic phenomena in space black holes. These cosmic monsters are regions of space-time where gravity is so strong that nothing, not even light, can escape their grasp. They're formed from the remnants of collapsed stars, and their existence has captivated scientists and science fiction writers alike for decades. But what happens inside a black hole? What would you see if you were to cross the point of no return? Let's explore together. Our journey begins at the edge of the abyss, the event horizon. Picture this, a sphere in space, invisible to the naked eye, yet marking the boundary beyond which there is no turning back. This is the point of no return, where the gravitational pull of the black hole becomes inescapable. Imagine you're an intrepid space traveler approaching this cosmic precipice. As you get closer, you'd notice something strange. Time itself seems to slow down. This isn't a trick of the mind, it's the effect of extreme time dilation, a consequence of Einstein's theory of general relativity. From your perspective, time would flow normally, but to an observer watching from a safe distance, you would appear to move slower and slower, eventually freezing in time at the event horizon. They would never actually see you cross over. Now let's shift perspectives. From your point of view, as you plunge towards the event horizon, nothing seems amiss. Time flows normally for you. You might even look back and see the universe aging rapidly behind you, its light stretched and distorted. This is because the intense gravity of the black hole warps the fabric of space-time, causing light to bend and time to dilate. It's a mind-bending concept, but that's what happens when you play with the fundamental forces of the universe. As you cross the event horizon, you'd be greeted by darkness, but not emptiness. The immense gravitational pull would continue to drag you inward, toward the singularity at the heart of the black hole. The event horizon is a fascinating and terrifying concept, a boundary between the known and the unknown. It's a testament to the power of gravity and the strange, counterintuitive nature of the universe we live in. But our journey doesn't end here. We've only just begun to scratch the surface of the mysteries that lie within a black hole. So buckle up, because things are about to get even weirder. As we venture deeper into the black hole, we approach the heart of this cosmic monster, the Singularity. Imagine all the mass of millions of stars squeezed into a point so small it has no dimensions. At the Singularity, density and space-time curvature become infinite. It's a place where the laws of physics break down. Our understanding of physics is like a map, and the Singularity is where the map ends. Some physicists believe quantum mechanics might hold the key to understanding the Singularity. Quantum gravity could unify general relativity and quantum mechanics. Until then, the Singularity remains a mystery. Before we reach the Singularity, however, we have another phenomenon to contend with: spaghettification. This isn't something you want to experience firsthand. Imagine yourself falling feet first towards a black hole. As you get closer, the gravitational pull on your feet becomes significantly stronger than the pull on your head. This difference in gravitational force, known as a tidal force, stretches your body like a piece of spaghetti. The closer you get to the Singularity, the stronger these tidal forces become. Eventually they would become so strong that they would rip you apart, atom by atom. It's not a pleasant thought, but it's a consequence of the extreme gravitational gradients found near a black hole. Now you might be thinking, well, that's comforting, at least I wouldn't have to face the Singularity itself. But remember, spaghettification is just a consequence of the extreme gravity near a black hole. It's not the main event. The Singularity is still there, waiting at the center of the black hole, and everything that falls in, including your spaghettified remains, would eventually end up there. The good news is that spaghettification is more of a concern for smaller black holes. Supermassive black holes, like the one at the center of our galaxy, have a much gentler gravitational gradient, so you could potentially cross the event horizon without being stretched into oblivion. Of course, you'd still have to deal with the Singularity eventually, but at least you wouldn't be ripped apart in the process. It's a small consolation, but a consolation nonetheless. But what lies beyond the singularity? What happens to the information that falls into a black hole? These are questions that continue to puzzle physicists today. The singularity is often described as the end of space-time as we know it, but what does that even mean? Does space-time simply cease to exist, or does it continue in some form that we can't comprehend with our current understanding of physics? Some physicists believe that black holes might be connected to other parts of the universe or even other universes through hypothetical objects called wormholes. Wormholes are like tunnels through space-time connecting two distant points. While wormholes are a fascinating concept, they remain highly theoretical. We have no observational evidence for their existence, and they would require exotic forms of matter with negative energy density to keep them stable. Another possibility is that black holes are not as black as we think. Stephen Hawking proposed that black holes might actually emit a faint radiation, now known as Hawking radiation, due to quantum effects near the event horizon. Hawking radiation, if it exists, would be incredibly faint and difficult to detect, but its existence would have profound implications for our understanding of black holes and the nature of information in the universe. The truth is, we don't know what happens beyond the singularity. It's a realm where our current laws of physics break down, and we need new theories like quantum gravity to explore it. It's a frontier of knowledge that beckons us to push the boundaries of our understanding. Black holes are some of the most fascinating and mysterious objects in the universe. They challenge our understanding of gravity, space-time, and the nature of reality itself. While we've made significant progress in understanding them, they continue to hold many secrets waiting to be unlocked. The study of black holes is a journey into the unknown, a quest to comprehend the most extreme environments in the cosmos. It's a journey that will continue to inspire and challenge us for generations to come. Thank you for joining me on this mind-bending journey into the heart of a black hole. I hope you found it as awe-inspiring and thought-provoking as I do. Black holes remind us of the vastness of the universe and the mysteries that still await us. If you enjoyed this deep dive into black holes, don't forget to like, subscribe, and hit the notification bell for more fascinating content from Mind Vault. We're constantly exploring the cosmos, uncovering new wonders and sharing them with you. Until next time, keep asking questions, keep exploring, and never stop marveling at the wonders of the universe.